So to begin with, in the Islamic perspective, soil is actually the cleanest material on earth. Because why? I believe there's one practice in the Islamic religion that if you touch it with non-halal things and you want to wash it a few times with soil water, you know why? Because actually clay can actually helps clean away all the dirt. Actually, so dirt itself, I know, is dirty, but clean clay can actually helps you to clean the things, and it's already mentioned in the Quran. Yeah. Well, I don't make this slide because this slide is actually taken from the previous lecturer who is also Muslim, so I believe whatever he says. Okay, so these are the verses or the statements made by very famous people in the world about soil, which I don't want to touch. And what is soil? But I think I'm going to go straight to the point, yeah. How the soil begins. So now, for your information, soil does not appear as it is what you see, actually, because from the beginning of time, when Earth was first formed, it is actually the cast off of gases, and then they compress. Once they compress, then only they melt in the center. So soil actually begins with magma from the core. So when the magma is actually spews out from the core, it cools and then it hardens and it becomes a rock. So soil begins from rock, and from the weathering process by the elements such as wind and also moisture and also temperature, it breaks down into smaller pieces to the size of the soil that you can see today. But soil is not just the mineral rock that you can see from the magma. It can be a lot of things as well. Yeah, explain later. But before that, these are the terms that you're going to go through. What is soil science? And these are the so-called terms used to define soil, like pedosphere is the soil environment, pedologist is the soil scientist. And what we're going to learn today is soil genesis, how soil is being formed. So the process and the factors that form the soils from the rocks is what we're going to concentrate today. Yeah. So you can see the second point here. Soil is a dynamic natural body composed of mineral and organic solid gases, liquid and living organisms. So that's why I say just now, the soil is not just the rock. Rock here is part of the mineral. It can also be organic solid, like for example, dead matter from the leaves and plants. I think this is a majority component. It can also be gas. So don't think that soil is very compact. They are not actually. It may contain a few gas, very little, but these are the gas that are essential for plant growth, actually. Don't think that plants don't need gas in the soil. They need it. Yeah. And of course, gases also is needed for living organisms in order to breathe. So this one needs oxygen. This one also sometimes depends, but mostly oxygen is required. But of course, you need liquid because if without liquid, water specifically, there will be no photosynthesis and there's no life, like I can see. Yeah. So soil is a mixture of everything right here. And as you can see here, it encompasses of atmosphere, the gas, biosphere, the plant and the living animals, soil and water, the liquid, and also the particles, the mineral rocks. Yeah. So these are the diagrams that you can see. There's a mixture of soil. And the medium for plant growth, of course, in order to have plant growth, then you have you need to, oh, wait a minute. I think I still haven't recorded the video. Not only I realize. Wait, oh yeah, already started. Thank good. I think the system automatically started the video recording. But here's one thing. I think not all of you have switched off the microphone. So switch off the microphone now. Otherwise, you're going to hear your voice as well. Okay. So let's come back to the media of plant growth. So of course, media of plant growth, they need nutrients, they need moisture, water, and they also need air. So these are the very basic things, but you don't realize that they also need support because plants actually don't float on air. They need to be on something, either on floating on water, or most of the case they are supported by soil. So soil itself also serves as a supporting medium so that they can grow upright. They don't fall off the next day. Yeah, so these are the things. But not many people know that actually soil plays a part in temperature moderation. How does it happen? I think I will explain later. Yeah. But of course, I already told you that soil can absorb and can clean things because they have a very high ability to absorb toxin. And of course, the nutrients also is come from the soil. So these are the example. Without a proper support, trees cannot grow well and they fall off. So when they fall off, the root is uprooted, then they cannot absorb any moisture and therefore they die. So soil is important in that. And for information, not every soil having the same ability to support trees. Some soil are very soft. Some soil are too hard to support any life. So it has to strike a balance. Cannot be too soft, cannot be too hard. So the physical support that they have is affected by these a few physical parameters. Yeah? So in order to determine how much of physical support that a soil can provide, scientifically, we are going to determine these four parameters. These are the four parameters that some of it you will going to analyze yourself in the lab. Like for example, soil bulk density. Usually this is the first parameter that soil scientists were going to use to ascertain whether the soil is healthy or not. So in physical terms, we will determine the soil bulk density. So is it good to have very high bulk density? The answer is no. We want low bulk density actually. Because in definition, right, bulk density, if it's low, that means it have air inside. Yeah, air is good because what? With air, you have animals, you have air, you can also store moisture, they can absorb moisture. So these are the reasons. Usually, low bulk density is good. Soil aggregates, this one, we want high aggregates because why? When they aggregate, that means they stick together. Soil can stick together and they cannot be too sticky not like clay. Clay, I know they have very high aggregates, but because they stick too closely together, there's no air that goes inside, so also cannot. Too bad. And aggregates also related closely to porosity. Like I said, porosity gives you indication that they can absorb moisture and they have air inside. So high porosity is good, and therefore the stability. Now this one is not what we learn here because why? We are soil science that caters for environment. We are not going to talk about more on civil engineering. So if you have friends in civil engineering, maybe they're going to talk more about soil stability, but not in this course. Yeah? Move on. Why water and air exchange is so important? There must be a balance. Because why? If your root have only water inside, this will going to be eliminating all the oxygen that they have. And for your information, respiration, okay, photosynthesis and respiration is the two cycles a healthy plant should have. Okay, so you know what is photosynthesis, kan? Daytime, and they absorb carbon dioxide and water from the soil. So got water in the soil, this is okay. So this is okay only on daytime. But don't forget, at nighttime, every plant will have respiration, just like humans or animals. Because in this station, the respiration will happen in their roots. So their root will going to absorb not carb, their root will going to absorb oxygen. So if it is inundated with water, then finish lah. They cannot respirate and they're going to die off eventually. So that's why you cannot give too much water to your plants as well. Too much water will suffocate them and will take away their respiration at night. So you have to strike a balance. Yeah? Too much water is not good. Too little water cannot do photosynthesis. Temperature moderation. Now, why soil can moderate temperature? Because if a healthy soil have enough organic material, they will also absorb moisture. Now, the presence of moisture in soil is very crucial in order to moderate temperature. Because what? Water can absorb a lot of heat. So if there's any sudden rise of temperature due to uh, intense sunlight, there's a hot day, only sunlight, but if the soil have enough moisture, there's no problem yeah. Soil will going to maintain a stable temperature, plus minus around 30-25 degrees if you're talking about Malaysian temperature. So that's why presence of water is important to moderate temperature. And I think this one you can read it yourself because this is a continuation of explaining how water and moisture presence in soil is important for various reasons. So I'm going to skip it for obvious reasons. We need to finish short down by 11. Yeah. Okay. So the next part that I'm going to talk about is nutrient. Now we all learned that nutrient comes from soil, but where exactly? It comes from two sources. Although this slide tells you that the source of nutrient comes from organic matter, which is true. I have to say it is true because why? The organic matter that we're talking about here, examples could be plant matter, like the leaves that drops down into the soil. Those leaves were going to supply potassium because all plant matter, the highest element in plant matter, other than carbon, is potassium. So apart from potassium, some may have like calcium. But potassium is a micronutrient for plants, so they can absorb back. And some of the plant matter also have high content of nitrogen. So you have potassium, you have nitrogen. Um, but there's one macronutrient that's not here, which is phosphorus. So there comes another organic matter. Phosphorus comes from the manure or the waste coming from animals like birds. So birds, when they poo their manure, rich in phosphorus, so that completes all the nutrient cycle. So organic matter is the main source, but there is another source which is not mentioned here: the minerals. You see, some minerals they are very rich in a certain element, like limestone. Limestone is very rich in calcium and carbonate, so calcium also will serve as a nutrient. Some of the minerals they might be very concentrated in phosphorus, like phosphate fertilizer. Rock phosphate is a mineral, but they are nutrient as well. Yeah? So it could be from minerals and also majority. So these are the nutrients that a plant may need. We will come back to this, so don't worry. I will tell you which one is macronutrient, what happens if you don't, and whatnot, yeah? So just like a introduction to you. Now, this slide is very interesting in a way that how does mineral and also organic matter releases their nutrient? Of course, minerals, they are initially crystalline. They are like rocks. It's not easy, not to say not easy. It is not easy to release all those nutrients from minerals because if we say they're crystalline, that means they are completely surrounded by a lot of individual ions and they are bind with very strong ionic bond, sometimes covalent bond as well. But most of the time it's ionic bond because it's crystalline. And in order to release these ions, you will need to make sure that a lot of water, so you can see a lot of these circles, guys, these are water. They need to go in. Once they go in, they separate these crystals and then slowly they dissolve it, and once these ions are dissolved, then only they are available to the plants. So remember, yeah, plant roots cannot absorb crystalline minerals. They only absorb the solubilized crystals, the solubilized minerals. Yeah. Only when they dissolve, then they can absorb it by plants. So these are the things that I will not touch. I'll leave it to you because why? There will be subjects coming that we're going to do in detail. So well, I think you have seen this before, kind of nitrogen cycles. So make sure you get familiar with yourself of these nitrogen cycles. Why? This is what we learn in agriculture. And practically speaking, this subject relates closely to the soil science subject in agriculture. Some of them you might going to say, hey, I'm going to touch a lot with nutrient because a healthy soil is enough nutrient, and nitrogen is one of them. But too much of nitrogen is bad, which is true. That's why we are here. And in order to determine whether the nutrients is too much or not, this diagram shows you how much of nutrient against the pH. So the availability, the solubility of each of these elements depends heavily on pH value of the soil. Too acidic is not good. Too alkaline also is not good. It must strike a balance. So that's why you see most of the nutrients are good at pH 6.5. I will come back to this later in a subject called soil acidity. So don't worry about that. Now, the other point of soil is that it protects us against toxin. And why is that? Remember clay that I mentioned to you earlier in the first slide? Clay is so good because clay, one thing they have, very small. they have high surface area. Whenever anything that is very, very small like clay, they can have like very high surface area. And because of that, they can absorb a lot of pollutants of that. Of course, not there's more than that because clay also is negative charge. A lot of heavy metals are positive charge. So that's why they can absorb it. But most of the time, like the main reason why clay can absorb a lot of toxin is because of their high surface area. Okay, now only we come to the main point here. I have another, I have another 40 minutes to talk about the origin of soil. Because why? This is the intended study. Okay, today's lesson we are going to learn about the origin of soil, how soil is being formed. Yeah. So, like I said, the original form starts from rock, from magma. It cools, and then it started off with a rock. And let me show you how the question is, which I will not going to answer. But you know the point, yeah. Why it is so important that we learn about soil? Because the entire process is actually ongoing. Now, the soil forming process or soil genesis happens all the time. And why this is so important? Because soil genesis, although is a process to define how soil is being formed, it is also closely related to soil erosion because the element is the same: water, rainwater, as well as wind from the air movement. So you can see lah, one of the factors in soil degradation is erosion. So it's good also lah, that you learn the entire process all over again. What factors that influence the soil forming process is exactly the same as erosion. So you can see lah, what is soil profile. Soil profile is what we can see right here. It's like a column, a cross section, vertical cross section of a soil that is cut down, and you can see different layers. Now we don't call these layers, we call this horizon. So how many horizon can you see here? Number one, the yellow. Number two, the round one. Number three, the light yellow. Number four, the bright orange, and lastly, number five is the pink level. So you can see all different horizons, and like say to say lah, you can but memorizing the horizons, the symbol, and also what they are, because these are the things that we're going to learn. This is fundamental soil science. Yeah. But of course, these are now soil science is not about theory; it's more about sight and practical things, things that you can pick up and you can feel and determine. After all, this is what farmers do. You don't expect farmers, the poor farmers, to have high-end equipment and they can know the essential things. Some good farmers, like the traditional ones, they can just pick up the soil, rub a little bit, and they know whether that soil is good for planting or not based on the experience. Because why? Yes, you can do it. Because a lot of telltale sign they can get from the soil. If it's healthy, you will know straight away the moment you pick it up. And this is why we know it, because from the texture itself, we will know whether they have the right texture to allow moisture to go in, to allow air to go in. And from the texture itself, we probably can kind of guess how much of nutrient as well. Of course, that is not the definite, the most conclusive way to determine nutrients, but we can tell roughly, okay, how much nutrients the soil should have. Now, don't worry about soil texture because why? I think this experiment is the one of the many experiments I can do at home. You just go to any sites that have soil, you pick it up, and then you can rub with your fingers and you can determine soil texture. So this is one of the lab reports that you're going to produce now. Maybe not in week 2, but later. Week 6. Okay, the mineral part of the soil is either sand, silt, and clay. So sand is the coarse one that you can feel with your fingers. Sand. Silt is the river bed sand that you can see. It's very fine, but you can still feel the coarseness. Clay is something that you can get from Sawabadi. It's smooth, it's gray color most of the time, and it's mostly absorb a lot of moisture. But when it's hardened, it cracks. These are the things that you will see from the mineral part of the soil. And these are the results from weathering of rocks and mineral. Weathering is a process where it breaks up due to the elements of temperature and also wind and moisture. Okay, now I think the last question probably we don't need to go and we go straight to the weathering process. And as you can see right there, these are the result of wind weathering. Now, usually when there's a horizontal cracks, if you can see horizontal cracks, these are usually the results of wind erosion. Because why? Wind does not move from top to bottom. It's not moved vertically. Usually, what we feel like the wind moves horizontally from left to right or right to left. Yeah. So that is why you can see all these signs of weathering. If it's horizontal, is due to the wind. However, if you look at it, the same diagram also have like some waterways or channels. These are the channels that are result from vertical movement of rainwater. So rainwater, of course, are formed from the sky, and then it just flow down to with the gravity, with the force of gravity, and hence whatever they can see the cracks vertically, that is a result of weathering by rainwater, not wind. Rainwater. You see this. Now, this is a very interesting diagram because apart from the elements, the environmental elements that do all this weathering, there comes one tree, and this tree is very resilient. It grows from the rock. It's rare, but it's not impossible. Because why? They can grow because trees can actually burrow their roots deep into the rocks. They can do it because why? They can release enzyme, they can dissolve the rocks and becomes a nutrient, and they can lodge themselves inside. Now, because of the movement from the roots, it will also cause the some sort of a breaking mechanism into these rocks, and it helps. It also part of the weathering process, but it's more from the biological side. Yeah. So as you can see right there are a lot of ways that rocks can be broken. Most of them due to the elements of the environment like wind and also rainwater, but also some biological factors from the trees. You see, trees is one, but you can see right here, lichens. You don't know what is lichens, kan? Okay, bahasa Melayu is called lumut. Lumut, you know that the green color ones that grows on top of the rock, these are the ones. Believe it or not, lichens can also help in soil forming process because when they grow on top of the rocks, they extract the nutrient. They dissolve the rocks and becomes a nutrient, and they grow carbon materials on top. So that helps. That is part of the soil forming process. It turns rocks into organic part, and this process, having lichens on soil on rocks, form the soil that we have, is actually good, much better than the erosion that happens using through wind and also water, rainwater. So the factors, okay. So these soil forming factors is developed by a guy called Hans Jenny, and you can see there are 5 factors over there that encompass CL, that means climate. So climate is the environmental elements that I talked about just now, temperature, so moisture. O means organism. So this organism may be trees, as you can see just now, or the living organism that also includes microorganism. Yeah, microorganism can also do a lot of damage to the rocks, especially those that can produce acid that eats away the alkaline minerals. Are the relief, the topography, the slope, and the landscape. Because why? If you have a very steep slope, then it helps the erosion by rainwater. Because rainwater can come down very fast and they can hit the rocks with high velocity, and it helps makes the erosion or the weather erosion faster. And of course, it also depends on the parent material. So this parent material comes from how strong is your rock. Not every rock produces the same way. Some of the rocks they are very soft, some of them very hard. So the parent material also determines that. Time, of course. The longer the time, the more weathering process is going to happen. So these are the 5 factors that I think you should know. Yeah? Because why? This is what we need to learn today. So know these 5 factors. Yeah. Now I would like to make a distinctive difference between weathering process and erosion process. Now, although I say the weathering and erosion process, the process is very similar, but there is one very clear difference, in which the difference for erosion is that once the once the breaking of rock particles occurred, there are the removal of this material away from the site, which means that after the material has dislodged and broken away from the rock, it will be carried by the wind or the rainwater away from that rock. So that is erosion. So what happened to weathering? Weathering also have the same process, but the particles stays put. It does not move anywhere. There's a difference there. So you have physical weathering due to, let me show you all the points first. So the physical weathering occurs most likely in temperate countries, like maybe not so much in Malaysia, because why? We don't have this first part, the freeze-thaw weathering. Because why? Where it got snowy in Malaysia, we don't have freezing. For the most is we're going to have a cool night at 25 degrees. For information, 25 degrees is not cold enough, yeah. So if you don't believe me, if you don't know how this works, you can try it yourself. Have a plastic bottle, fill it completely with water, put it in your freezer, and then come back the next day. See what happened to the bottle? You understand what happened, lah, yeah? And then it explains everything right here. I wish I don't want to read it. You can read it yourself, but better still, try it. Take a small uh, take a small mineral water bottle, fill it with water, and put it in the freezer. You know what you see. Number two, biological weathering. I think I've explained to you just now about the tree and also the lichens, so I won't talk about it again, and I go straight to the next two. Exfoliation or unloading. Okay, so let's read the definition. When rock at the Earth's surface is worn out, after rocks that has formed deep in the Earth is exposed at the surface, it expands and gradually breaks into sheet. So this is due to the expansion, due to the rocks, probably due to the factors from uh, the shape of the rocks. Because some of the rocks, they are not like evenly shaped, like round shape. They might have edges. Now, these edges they are also subjected to the weathering process by the rainwater, for example, but also the act of gravity. Because when you have one shape that have extended out, they might fall off naturally due to gravity. So that is one example of exfoliation or unmoving. That is why you never see like probably not most of the time you can see rocks that are like have segments. If they have segments, probably they just broke off from the big rocks, the big rock chunks, and they have segments. But after a long time, they were going to turn into more rounded shape because why the edges they will just naturally go off. So the next part is a more complicated one. Earlier, we discussed about the physical weathering and also the biological weathering. Now is the more complicated one, chemical weathering. How does it happen? It happens, of course, through chemical process. So as you can see right there, the best to use right here is the limestone. You must have heard two words. Limestone cave inside there, they have stalactite and stalagmite. What makes that happen? This process, chemical weathering. I think you can read yourself what exactly happens. It all started with rainwater. Rainwater is slightly acidic because of carbon dioxide. And because of that, they can actually dissolve slightly limestone, which is slightly alkaline. So you can see slightly acidic, slightly alkaline. They have neutralization and they dissolve. So that is how your stalactite and stalagmite are being formed. Because of rainwater that seeps through into the caves, they slowly build up and precipitate. When they're concentrated, they will precipitate, and that is why you have your stalactite coming from the ground. So that is acid and base reaction between limestone and the carbonic acid in the rain. And like I said to you just now, due to the unloading, the unloading mechanism, all these segmented, all these rock sections that are extended out from this original body. Now, why there's a tip right there? Probably they just fall off. So it's very natural that they fall the tips somewhere. And And then these tips are actually very exposed to erosion and also chemical weathering. Because why? These tips, their surface area, I mean, the area is very small. And to react with it, it requires a small amount of acids to react. So that's why the tips also is very exposed. And usually they are the first one to be eroded and weathered. So most of the time, like, the tips will going to turn into rounded shape very soon if the rain is very acidic. So chemical weathering also produces clay because what? Like examples just now of limestone, when they are like newly formed into stalactite or stalagmite, they are just recently precipitated and they are not as hard as its original form. A little bit of pressure, we're going to smudge it into powder. Example, the chalk, the kapoga that you use for writing in your blackboard. These are the examples of the small particles that are precipitated due to the chemical weathering process. And just to sum things up, these are the process also that produce the clay. Of course, to produce clay, they have like maybe involving some of the tougher minerals. So in order to break these tougher minerals, you might have other than chemical weathering, maybe a little bit of physical weathering as well. But chemical weathering is one of the ways to produce clay. So break it down from larger rocks into smaller clay. And from this chemical weathering process as well, they will release the nutrient and allows the lichens, all those humus that grows on the surface. So slowly they'll eat away all the nutrients and convert it into carbon. So that is one way, lah, yeah. Chemical weathering can help the process. Now, this is the same thing that I have presented earlier about limestone. So these are the examples. Um, I'm going to tell you one story, lah, yeah. This is what you can see from underground river. So underground river usually is carved out from limestone.
Oh, tak ada kreatif. Tak khabar.
Can you switch on the microphone, please? Yes, switch on the microphone. Okay, now, um, one story to tell lah. The entire KL, not the entire KL. I would say around 30 to 50% of the KL is made out of limestone, and they have a lot underground river. Where is this river? They're on the east side of KL. Places like Bukit Bintang and all the big shopping complex, the Golden Triangle. Yeah, all those places, they are filled with limestone. So they have a lot of underground river. Well, they're filled with river. I mean, they're filled with water, so no issue. Lah. But let's say if they're drained out, like last time when they're trying to build an LRT station over there were sinkholes. The entire roads, the entire road, some part of the roads in Bukit Bintang, they are actually sunk. But of course, lah, if you are into adventure, now these are like the underground river that were available in so many places. Some in Thailand that the students actually went there and have some adventure and unfortunately were trapped inside. So very fascinating. They are formed due to chemical weathering of underground limestone. Example of chemical weathering is due to reformation of acids. And hot spring is one example. Because why? Any places with volcanic activity will carry a certain amount of sulfur. Now, sulfur, if it's exposed, now we can see right here, sulfur is yellowish in color. But if it is exposed to air with oxygen and comes with enough temperature, this sulfur will turn into sulfuric acid. Any issue? Yes, there is an issue. Because with this sulfuric acid, if it travels out and it comes in contact with alkali minerals, they will do the same thing as the carbonic acid. So this is one example of how nature can expedite the chemical weathering process due to the formation of sulfuric acid. So these are the chemical equations, Laya, that I won't touch, but I'm sure you know how it works. If it's hydration, now why hydration is one factor here? Because what? Now hematite and gypsums, when they are in their original form, they are like no color, very compact. But once these two minerals they comes in contact with water, two water molecules will going to seep into the crystalline structure. So what will happen? they suffer expansion. So this mineral will going to expand a little bit, and of course, lah, maybe will suffer as well, a weakened physical structure of these minerals. So hydration is one. Hydrolysis is where dissolution happens. When you have a salt and you dissolve in water, hydrolysis is what I mean. Hydro means water, lysis means breaking. So it's essentially breaking some minerals by using water. An example is dissolution, water, and that happens. Of course, the hydrolysis can be so many things, especially in organic chemistry, but it's not related here. So the examples here is by dissolving minerals, that a case of hydrolysis. Dissolution is another one thing that you is follow up from there. So after hydrolyzing the larger crystals, then it will further dissolve and isolate. So after dissolution, the cations and anions they are separated in much larger distance so that it will be available to plants. So dissolution is a good thing because why? From dissolution, minerals, the nutrients from minerals can be absorbed by plants. Then carbonation and all acid reaction. So just now we've gone through carbonic acid and also sulfuric acid. How does carbonation and acid reaction happens? We already explained, so we skip. Okay, now oxidation is some, probably I did not touch everything. But I may have said just now sulfur exposed to air suffers oxidation and gives you sulfuric acid. But there are other things that also may be oxidized as well, like for example your iron compound. If the soil have iron too, it will appear bluish. Actually, iron too is green in color, but when you see it in your eyes, it looks like blue color. That's why clay. If you look at some clays with irons, they are blue in color, but after you expose into air, it slowly turns into orange or maybe brown color because it turns to iron free. So these are the reactions that may happen to the soil. Yes. Minutes. As I have 40, 16 to go, so I think I can finish in 10 minutes. So I'm going to go really quick with the weathering process in which I will skip things that I have talked about. So earlier that slide, I talked about physical weathering. And this is about the weathering, biological weathering in forests. Now, I don't want to like dwell too much, but as essentially what happened in the forest is more of biological weathering. But there's so many plants that can extract nutrients and whatever that they drop down, that leaves or that tree branch or maybe that plants all together, they contribute to the biological weathering. And this one is a very different kind of weathering that is not happening in Malaysia at least. Well, I think it does. If it happens in Malaysia, this will be at the uh, edge of the cliff near the seaside. So is there any site in Malaysia that have a cliff and a seaside? Very rarely we have these kind of scenes because in Malaysia, when we talk about Malaysian seaside, it's always beach. I don't think we have this here. But anyway, now wind weathering happens when there's a lack of water, lack of rainwater that have vertical weathering. So you can see that most of the weathering they are vertical, no, horizontal. Sorry, it's horizontal due to the horizontal movement of air, dry air, hot or maybe even cold air. So it happens usually in arid regions like the deserts of Australia, deserts of the Arab region. Yeah, as long as you have large continent, you're going to have this kind of weathering. But in Malaysia, we have a lot of this weathering of rocks. You can see that these are the silt. So this is collected from the river bed and it's compressed. This is what it looks like. It is not really smooth, but it's small enough. But other than that, you can see a lot of pebbles, very nice pebbles coming from various types of minerals. Some of them are sediment rocks. So this one, as you can see right here, brown colors, usually those that is not translucent. You cannot see through. Those are coming from deposition and compression and gives you these sedimentary rocks. The see-through ones with crystalline structure, these are usually from granite or maybe some very precious metal, perhaps. So these are the ones that comes from the weathering the water that flows through it. So they are round shape. You can see that most of them they have round shape. Yeah. And apart from pebbles, you can see silt and may have can see sand. So these are probably sand particles. Oh yeah, yeah, they are sand particles. Because what you can see here, 2,000 micron. It's actually 2 mm. 2 mm means sand particles. So these are sand. You can see sand are different in all over the world based on their minerals that they are coming from. So you see, not every place in the world they have the same mineral. But silt, as you can see right there, silt they have a very particular size. While sand just now remember is 2 mm or below. Higher than 2 mm, they are not considered as sand. This you have to remember, yeah. Sand is 2 mm. Silt is between 0.5 mm to 0.002 mm. So you can say that the sand, I mean the size, the range, the particle size range for sand particles is between 2 mm until 0.05 mm. So those are the size for particles. Whereas silt, 0.05 until 0.002 mm. So these are the size range that you should know. So pandai lah you want to memorize macam mana ke, but these are the size that you should know, yeah. Now, usually silk they are not having too much of application except to find ways into your scrubs, the scrub that you use in your cosmetics, sometimes in soap as well. Um, like for example, this one. These are available in all Indonesia. At least I haven't seen any silk soap just yet. But these are the like the source of silk. Now, silk are produced due to natural weathering, but in temperate countries like in Canada, for example, they have rivers that they frozen occasionally because why? They have winter. So of course, river can frozen up, and you can see these are the the melted region. The other one, the right hand side, they are still frozen. So you can imagine these ice sheet, they are like tons. So you can imagine they are rubbing tons of ice with the bottom. So possibly the bottom, I mean the riverbed have rocks. So you can imagine tons of weight rubbing against those rocks and they're moving down actually. This ice sheet they're moving down. So you can imagine that the rubbing action actually can break down larger rocks into smaller silt particles. So this is one way glacier can make silt. And when it comes during summertime, this is what riverbeds looks like. All those silt particles, they are flying around due to the movement of wind. And in other words, these are like, because it comes from glacier, so we call it glacier flower. We don't have glacier flower here. But in China, they have a lot of this and they call it loess. And usually they are formed in near the river in temperate countries. So not just in the United States, but also available in China. And then skip straight to river. Now I'm going to stop maybe a little bit longer here because we have this in rivers. So our silt is formed from the movement of water, weathering of water due to river water movement. So you can see like this is not new because why? You go to any river in Malaysia, you're not going to see like clear water like this one. For sure, you're going to see cloudiness, suspended particles. I cannot say all of the suspended particles are silt, but most of them probably do. And this is the lowest in Mississippi, and you can see one thing coming out here. These are like fossils. So fossils may be trapped inside here, and they are very good materials for archaeologists to study things. And these are the lowest in the China region. And most of the time, they are very near to the inner part of the Chinese region, where you have what Great Wall of China. And yeah, here's the story. The Great Wall of China actually primarily made by lowest clay, the silk, not clay, it's the silk. And they are built with the dead soldiers that they murdered during wartime. They help a lot in a way that they provide calcium, and calcium actually provides a binding apart from the organic matter from the dead bodies. Well, that is a story. It's not from me. I heard it from uh, source, internet source, whether it is believable or not. Maybe it's true, maybe it's not, but so far there's no scientific evidence or any proof that there's a suspension. It's just like legend. Okay, next part. From the silt particle, we move on to the last component of the mineral components, the clay. Clay is smallest. How small? Smaller than 0.02 mm. Anything that's smaller than that, considered as clay. So that is why it can reach up to nanoparticles, nano size particles. So if you push down 3 decimal point, 1, 2, 3, essentially 2 microns. So this is micron size, and it can be even smaller into nanoparticles as well. And because of that, it poses different issue. Now, because clay are so small, they absorb a lot of moisture. And when they absorb moisture, this is how it looks like. It's sticky. No water can go through. And that is why clay is not usually a good soil material for planting. And it requires some intervention. Either you add more organic matter or you add coarser minerals. And the reason why it doesn't grow is water cannot grow in, and when it dries, it cracks. And during cracking time, it also can split the roots and it will kill the plants as well. So I think I'm going to skip this one and the end. So exactly time. Now, to recap what I have explained to you earlier, what you need to learn about this chapter is that you need to know what are the factors that influence the weathering process. So there are 5 factors. Hope you know that. And how does the weathering process occur in Malaysia and also in arid regions? So some places they may have wind erosion or weathering due to the wind. Some places, like in Malaysia, we have high humidity with high rainfall. So the rainfall, we're going to carry out most of the erosion, apart from the biological erosion from the plant growth and so on. So these are the things that you should know lah, initially. Uh, so put it simple lah, the soil forming process is what you should know. Now there are other information like nutrients and some erosion part. Don't worry if you don't get it, because later on there will be a specialized topic on the on the specialized subject chapters that talks about this topic again. So we're going to come back and talks about nutrient, soil, chemical process again. If you don't know lah, yeah. And I hope you know what other examples that cause weathering. And of course, you must know what is sand, silt, and clay lah, and the particle size. Yeah? So tips already given. It's just whether you catch it or not. Of course, you should, because this is a recording session. So I think I will going to record the question and answer session. So I'll start recording right now.